Imagine you could shrink down smaller than the tiniest speck of dust. In this microscopic world, everything you see around is made of tiny, incredibly strong building blocks. Are you curious to discover what these are, how they interact, and how they explain the vast variety of materials we see in the world? Buckle up, because our journey into the atomic world is about to begin. Hi learner! Welcome to Chemistry Courses. Today's topic is atomic theory. Let us explore atomic theory timeline. As you can see, there were various theories proposed over the timeline right from 600 BCE to all the way to 1920s. 1. Paramanu, Kanada Sutra. 2. Solid sphere model. 3. Plum pudding model. 4. Planetary model. 5. Nuclear model. 6. Quantum model. Vaisheshika Sutra by Rishi Kanada in 6th century BCE. Maharishi Kanada was ancient Indian scientist, sage and philosopher who founded the philosophical school of Vaisheshika and authored the text Vaisheshika Sutras or aphorisms. He pioneered atomic theory, described dimension, motion, chemical reactions of atoms. Theory of Paramanu was formulated by Acharya Kanada 2500 years before the Dalton theory. Maharishi Kanada, also known as Uluka, Kashyapa, Kabhaksha, and Kabhuj. Vaisheshika Sutra explain much more than just atomic theory. According to Maharishi Kanada, matter consisted of indestructible particles called Paramanu, now called atoms. A Paramanu does not exist in the free state, rather it combines with other paramanas to form a bigger particle called the Anu, now called a molecule. Democritus defined the term atom, which comes from the Greek word atomos, meaning indivisible. Then comes solid sphere model by John Dalton. He is a British chemist and physicist who adapted concept from Paramanu theory and proposed the solid sphere model in the early 19th century. According to this theory, atoms are tiny balls that can't be broken and are all made of the same material. This theory helped explain how different chemicals mix together and what makes them different. But there were some limitations to this theory. Next is Plum pudding model by J.J. Thomson. He is an English physicist known for his work on the nature of electrons and proposed the plum pudding model in the late 19th century. According to this theory, atoms are like plum pudding, with tiny positive charges scattered throughout a cloud of negative electrons. This theory helped explain why atoms have a neutral charge overall and why they emit light when they collide with each other. But there were some other limitations to this theory as well. There comes Nuclear model by Ernest Rutherford. A New Zealand-born physicist known for his contributions to nuclear physics, introduced the nuclear model in the early 20th century. According to this theory, atoms have a nucleus with a positive charge and most of the mass, surrounded by electrons that orbit like planets. It explains why particles can pass through or bounce off atoms, and is the basis of our current understanding of atomic structure. Again, this theory also had some other limitations. This led to another theory called Planetary model by Niels Bohr. He is a Danish physicist known for his pioneering work in atomic structure who proposed the planetary model in the early 20th century. According to this theory, electrons orbit the nucleus of an atom in specific energy levels or shells. This theory helped explain why atoms emit light and why they absorb certain colors of light. It also helped explain the stability of atoms and why they don't fall apart. But there were some limitations to this theory as well. Currently, we have Quantum model by Erwin Schrödinger. He is an Austrian physicist renowned for his contributions to quantum mechanics who proposed the quantum model in the 1920s. According to this theory, Electrons exist as a probable wave-like pattern around the nucleus, not in a specific orbit. It explains why electrons act like particles and waves, and is the foundation of our understanding of atomic structure and widely used in modern physics. Major limitations to this theory are: 1. Mathematical complexity of the model. 2. Requires advanced mathematics to calculate electron probabilities. 3. Doesn't provide a simple visual representation of atomic structure. Follow Svadhi.in and Atharvanava.com for more content. Let's meet in next topic. Happy learning!